morning everyone, welcome back to Bytecode Technical Solutions. So in this video we are going to look at the topic stack, which is the first data structure in the subject data structures what we have studied in the previous video. We have introduced about data structures subject in the previous video. In that I told that from the next video onwards we are going to learn each and individual data structures in more detail. So today it is for the topic stack. These are the following contents what we are going to study in this or understand in this video. So first we will understand about what is stack. Later on we will understand about the various different stack operations. So we have insert operation, which is also called as a push operation. We have delete operation, which is also called as pop operation, and we have display operation that displays the contents of the stack. So basically, before going in depth about the stack, what is stack? Let us understand about that. So we have seen many of the we have visited many of the hotels, and even we have seen many of the libraries. They are going to keep the book one above the other. In the hotels they are going to keep the plates one above the other, and not even that, whenever we try to count any the coins, we will also keep them as one above the other. You can see the all the three pictures available here. So normally all the plates in the hotel or cafeteria are placed one above the other. So these plates are inserted from the top. If the plate is required, we will take it from the top. It is not like that we are going to take the plate from the middle or from the last or from the down. Similarly, whenever I need any book, so I will take the book out in the stack of book from the upside, and whenever I try to insert a new book in the stack of books, I will keep on the upside itself or at the top of the stack. Okay. So similar content we are going to observe in our data structure subject. So whatever the content we are going to remove, either the book or a plate or a coin, we will remove it from the top. And if I am going to insert any new book or insert any keep any new plate in the stack of plates, I am going to keep it on the top. I am not going to insert the plate in the middle, or else I am not going to keep a new plate in the down part. That will be not so easy. I have to lift all the plates and then I need to place it, and that is not so convenient. So let us understand the same thing what we follow in the data structures. So basically, as we understood in the previous examples, so stack is a special type of data structure. What type of data structure it is? It is a linear data structure. In here the elements are inserted from one end, and from the same end the elements are deleted. That is, from the top of the stack we are going to insert a new element, and from the same end we are going to delete the element. So it behaves with the property of the element what is last inserted in the stack body will be the first element that is going to be removed out of the stack body. So it exhibits the property of last in first out. So stack is also called as LIFO data structure. Next, stack operations. The various operations what that can be performed on the stack are: first one, insert. So in the insert operation, an element can be inserted at the top end. So here especially we call it as push operation. The insert operation is called as push operation in the stack. Next, delete. So an element can be deleted from the top end only. So here especially the delete operation is called as pop operation. Next is display. Here we are going to display the contents of the stack. Later on we check out with two more different concepts, that is overflow of the stack and underflow of the stack. which are among the operations. Overflow tells that the stack is already full, we cannot insert more elements in the stack body, that is called as stack overflow. Underflow tells that the stack is already empty, we cannot delete the elements from the empty stack. So that tells about the underflow of the stack. Right now it is just a description. Full detailed study we will do in the upcoming slides. So here are these operations what basically we do study in the stack: push, pop and display. Now let us start with the push operation. So push operation is nothing but inserting an element into the stack. Okay. So here one by one we are going to insert. At one time we are going to insert only one element. So consider the example what is that you are visualizing on your screen. Here we are taking the stack size as 4 and we are going to insert 4 items. The items are 30, 20, 25 and 10. So at the beginning when you observe, the top of the stack is pointing at -1. This -1 in the stack body indicates the bottom of the stack. It is the initial condition of the stack. Whenever you try to initialize a new stack, it is the initial condition of the stack that the top will be pointing at -1. The top will be pointing at -1. So top is the only pointer that points to the highest most element in the stack body. At the initial case there are no elements. You can see 0th, 1st, 2nd and 3rd locations in the stack body, they are all empty. Okay, they are all empty. And here the top pointer will be pointing at the bottom of the stack. So this bottom of the stack we will indicate by -1. Okay. So whenever the top is pointing at -1, we say it as empty stack. Yes. Next, at the first time I am going to insert 30. So since 30 is inserted, the top will be the one who is going to point to the topmost element in the stack. So 30 is the element available in the stack, that is the first element and the topmost element in the stack. So top will be pointing at that particular 30. Next I will insert 20. We can see that top will be marking at 20. Now here in this situation you can see there are two different elements available, 30 and 20. 30 is inserted at the first time, 20 is inserted at the next time. The last inserted element is 20. So the topmost element in the stack will be also 20 only. 30 will be the bottom element below the 20th element. So since 20 is the highest most element available in the stack body, hence the top is marking at that location, that is 1. Next 25 is inserted in the stack body. So now 25 is the highest most element in the stack body, hence top is pointing at that location, that is number 2. Lastly we are going to insert the 10. So here 10 is the highest most element in the stack body, hence the top pointer is marking at the location 3. There occurs some situation wherein we can say after inserting the element at the location 3, which is the highest most element, which is the highest most place that is been occupied. So here we can say that top is almost at the stack size -1 location. It says that all the empty spaces in the stack body are being occupied. There are no more empty locations available. So stack size is full. So if at all I want to try to insert any new more element, we cannot be able to do it. So this situation is called as overflow of the stack. So example is there here on the screen. Here the stack size is 4. After inserting 30, 20, 25 and 10, there is no space to insert any more items. So already the top is marking at the location 3, which is the stack size -1. Okay. So which is the location stack size -1. So more than that I cannot insert. It is similar to that of the situation wherein I have a bench available in my class that highest most occupies is 3 students. More than 3 students I cannot make an extra student to sit in that bench. So it will be very problematic if I make any other extra student to sit in a bench of the space or of the size 3. So that will be the overflow of the bench. It means student cannot sit properly. He does not have a proper space in that situation. Okay. So this situation is called as stack overflow. I hope you understood about the stack overflow. Next, once we understood about the stack overflow, now we are eligible to do the design for the push operation. How actually these items can be inserted into the stack. So consider the situation wherein already we have 30 and 20 elements being available in the stack body, and since the 20 is the highest most element in the stack, so top is marking at that particular point. Let us consider that I have 2 more elements available to be inserted to the stack body. Consider them to be as some random numbers 10 and 15. Now the next element to be inserted is 10. So I have 2 more empty spaces available. So I need to make the situation such that wherein I can be able to insert the 10 and 15 into the free spaces available in the stack body. Now let us understand that. So now the top, if I want to insert, so if I want to insert any item in the stack body, I should see that top pointer should be the one that will be pointing to the topmost position or the topmost element in the stack. If I am going to insert new element, so that will be the next topmost element in the stack. That is, even though 30 and 20 are already available, I am going to insert a new position. So a new element in the new position, so that position will be 1 unit ahead of the previous. That is, earlier the top was marking at 1. Now if I want to insert a new element, it should be at the position 2. Okay. So if at all I want to insert, I should see that the top is the one that is to be pointed to the empty location, so that I can be able to insert in that particular amount of space. So if top is marking at 1, already it is been occupied by 20. I cannot insert the new element. Okay. So first the top has to be made available to be marked at the empty location. There I can insert a new element. So to make this happen, what I will do is I will increment the top using the particular statement top is equal to top plus 1. So when I do apply top is equal to top plus 1, so the current value of the top is 1. So 1 plus 1, it will be 2. So automatically the top pointer will shift from the location 1 to the 2. So once my top is pointing at the empty location, there I can copy the next item what is to be inserted at the space in the array S, at the location where top is pointing at. Now the top is pointing at the location 2. At that place the item has to be inserted. What item has to be inserted? I am considering the item to be inserted is 25. So in this place 25 will be copied at the location 2 in the stack array S. Okay. Yes. So this is how I can insert the element 25. So suppose I have another element available 15. So if I want to insert that, then obviously now 2 at the location 2 where the top is marking at, imagine that 25 is inserted. Now if I want to insert a new element 15, I cannot insert at this place. Why? Because it is occupied by 25. Imagine it. So first I need to point out at the empty location. So now the empty location is 1 unit ahead. It means I need to again increment to the top by 1 so that I can mark to the empty location. Empty location next is 3. Okay. So once my top will move to the empty location, therein I can insert the next item, that is 15 at the place of 3. So this process is repeated until and unless the stack size, the top is marking at the stack size minus 1. It means up till all the elements are inserted. So once the top is at the stack size minus 1, it clearly tells that the stack is full. I cannot insert further more elements. So therein I need to write an error output, that is stack overflow. So now we are eligible to understand the same situation. So when we cannot insert an element into the stack, that is once the top is marking at the topmost position in the stack body, that is stack size minus 1, as in the figure what you are seeing. So previously we inserted 25 at the second position, 15 we inserted at the third position. Now top is marked at the stack size minus 1. Stack size value is 4. It starts from 0. So the topmost element location will be stack size minus 1, that is 4 minus 1, 3. So here that once the top is marking at the stack size minus 1, we can say that stack is full. You can see visually all the elements are being inserted and stack is literally full. Okay. So we cannot insert further more elements. So this can be written using the statements by using the if condition. If top is equal to stack size minus 1, we are going to print the error message, that is stack overflow. So once we print the error message, we are going to return back to the location from where it was called, that is we are going to return back to the main function. So the overall C function for push operation can be written as, here we are going to take item, top and the array S as the parameters that are being passed from the main function, and these are received as the arguments in this current function push. So top we will take it as a pointer. Why? Because top is just a address location what is going to mark. Okay. So as and all we understood, first we have to check whether stack is overflow or not. So for that case we are going to use this if condition where I am checking whether top is equal to stack size minus 1. If it is so, I cannot insert more elements, then I will print inside the if body, that is stack overflow, and go for return statement. This return statement will take me back to the main function from where the function push was been called. If suppose this top fails, if suppose this condition top fails, then what can I do is I can go for, if suppose this if condition fails, then what I can understand is that I have some more empty spaces available in the stack body wherein I can insert more number of elements. So to point out at the empty location, as we understood in the previous slide, first I will increment the top by 1 using the statement top is equal to top plus 1. Once the top is marking at the empty location, there I am going to insert the item at the particular place. Wherever the top is marking at in the array S, at that location I am going to insert the item. So in this way we are going to write this function. Next, let us understand the next operation, that is pop operation. So pop operation is nothing but deleting an element from the stack. Okay. Here also, as and how we insert one element by one element at each time, deletion is also done one by one or one after the other. So similarly, consider the elements that are to be deleted. There are 4 items available, 15, 25, 20 and 30. So one after the other they are to be deleted, and the stack size is 4. So you can see that the elements are being inserted in the stack body 10, 25, 20 and 30. Okay, here it should be 10, not 15. So 10, 25, 20 and 30 are already available and stack is full. I need to delete the element from the stack. As we understood, as the property of the stack, LIFO property we will follow. Last element inserted will be the first element to be deleted. So here the topmost element to be deleted is 10. So 10 will be deleted. So whenever we are deleting, we will mark first the element that is to be deleted, then we are going to do the process of deletion. So 10 is to be deleted, so where the top is marking at, so 10 will be deleted. So next after 10 is deleted, top will be marking at the next highest most element, that is 25. So next element deleted will be 25. After 25 is been removed from the stack body, the next highest most element will be 20. So top will be marking at that position. So once 20 is also being deleted, the next topmost element in the stack body will be 30. So 30 will be deleted next. So after 30 has been deleted, the top will be marking at the next most element, that is the bottom of the stack, that is top will be marking at -1. Already as I said, so top is marking at -1, it means top is marking at bottom of the stack, and it indicates that the stack is empty. We cannot delete any element from the stack body that no elements are, whenever the no elements are available. It is similar to the situation where in the bench no students are available and I am going to remove a student from the bench. Is it possible? No. So this situation is called as stack underflow. Okay, if I try to delete any element from the stack body where I can see that no elements are available in the stack, okay, at this situation top will be marking at -1. So this situation is called as stack underflow. For this case we will take the examples. So after deleting the elements 10, 25, 20 and 30, there are no elements in the stack and the stack is empty. You can visualize that. So in this case top will be marking at -1. So deleting any more element from the empty stack is not possible. Hence this results in stack underflow. I hope you understood about stack underflow now. Now let us try to see how to design this pop operation. Okay, so the first step what is to be done is, the first step tells that first we have to mark the element that is to be deleted. So the topmost element, it will be marked by the top pointer, so which is indicated in the array as s of top. So that will be read first. So we are taking a special variable called as item deleted, wherein we are going to store the topmost element that is to be deleted. Next what we are going to do is, here once the element is deleted, the next topmost element will be the down, that is it will be one level down, as you can observe in the figure. Once I delete 10, the next topmost element will be 25. So it is going to, the top pointer will be going to move from 3 to 2. It means 1 unit is going to get reduced. Okay, 1 unit is going to get reduced. So here each time I delete a new element or the topmost element from the stack body, the top pointer is to be reduced by 1. Hence here I am applying the decrementation. So this is done by using the statement top is equal to top minus 1. Okay, so there occurs some situation where top will be marking at -1 and we don't have any elements to be deleted. Okay, the situation when we try to delete an item when top is marked at -1, okay, this situation is called as stack underflow. Okay, we need to display the error message for this, and this we can represent using the statement if condition, as that what I have written here. If top is equal to -1, then return 0. So this 0 what I am returning, I am going to use in the main function. So as soon as possible I will be explaining you the program, the C program for stack operations. So at that situation you will understand this 0 value I am returning. This indicates that there are no elements available in the stack body. That's it. While returning back I am returning 0. 0 indicates what? There are no elements available. So the full function, the full C function to delete an item from the stack body, here we can write it as follows. So mainly we are considering only the top pointer and the array S. So we are going to take them as the parameters. So here I am going to take a new element item deleted. So I have defined it as of type int because I am taking it as the whole number. First, before deleting, I will check whether if the stack is containing any element or not. So that is what we check by checking the condition if top is equal to -1. If it is so, the condition satisfies, then we will return what? 0. If this condition fails, we will not execute the if body, we will go to the next line. So the next line indicates that first we will mark the particular element that is to be deleted. So the element will be deleted marked by the top pointer. So the top pointer, whatever the value will be there at that particular location S of top, so that will be marked by the item deleted. So first we will read it. Later on what we will do is we will decrement the top is equal to top -1. So once we decrement, the item that will be there available at that particular location will be deleted. Okay. So lastly what I am going to do is I am going to return the particular item that is to be deleted. So this value we are going to read it there in the main function to display the element that is to be deleted. Okay. So since here it is going to return the item deleted. The item deleted is of type what? Integer. Hence the function data type has to be of type what? Int, not void. Okay. It is to be of the type what? Int. So previously in the push function we saw that in the push function we have seen that there are no items, there are no value being returned back. Whenever the function is not returning any value, then we will take the data type of the function as void. Now here in the pop function we are going to return the item deleted variable or value. The item deleted value is of type what? Integer. Hence the return type of the function will be also integer. Okay. Yes. The last operation in the stack is display. So here display is the process wherein we are going to display whatever the elements are there in the stack body. So if elements are there in the stack body, we are going to display it. If suppose no elements are available in the stack body, we are going to display an appropriate error message, either underflow message. Okay, right. So now we have a situation wherein we have 3 elements available in the stack. We have what? 3 elements available in the stack. What are those? 25, 20 and 30. So these are to be displayed. So here in the array S, what we are using to implement the stack operations, it starts from 0, 1, 2. So this the lastmost, that is the lastmost element or the highestmost element in the stack will be always pointed by the top. So hence we can take it from 0 to the pointer top. The pointer top will be always marking at the position where the lastmost element in the stack body will be present. So this can be designed using the logic. So if I want to print the firstmost element in the stack, we will start displaying from the bottom of the stack, that is from the 0th location. So that is first we will display 30, then we will display 20, then we will go for displaying 25. So we can write using the printf statement. So printf %d and s of 0. S of 0 is what? 30. So 30 will be displayed. Next time I am going to use s of 1. So s of 1 is what? It is 20. So 20 will be displayed. Next we are going to display s of 2. So s of 2 is what? 25. So this statement printf is repeated many times, and this is the way of writing the worst programming. So we should not repeat the statements which are going to do the same functionality. Instead of that, we have different looping statements that repeat the same as many number of times as you wish. So either we have three types of looping statements: while loop, do while loop, and for loop. Among these, for loop gives the better performance. So since when I be using the for loop, I will take this index values 0, 1, 2 with the index variable I, and this I will be starting from the 0th location till the pointer top where it is marked at, because the pointer top will be giving me the last element available in the stack body. Hence I will take the I value from the range 0 to top. So this I can write using the for statement as follows. So for I is equal to 0, I less than or equal to top, and I plus plus. Why I am taking I less than or equal to top? Less than means, so the situation is something like top is marked at 25. If I take I is less than top, it will come up till 1. It will never go to 2. It will never go to 2. Why? Because top is marked at 2. Less than top means less than 2. The less than 2 is 1. So 1 means it is having the element 20. So it will print up till only 20. So the condition what we are taking is less than or equal to. Equal to specifies that we are also including the place where top is also marked at. So if top is equal to 2, so up till that I am going to read my I, that starting from 0 and then 1 and then 2, like that it is. Okay. Yes. So in this way we are going to print the elements in the stack body. Okay, right. But this statement has to be not executed when top is marking at -1. So we have to put an error message during that stage. So hence we can write the C function to display the contents of the stack as. So here we are going to use the parameters top and the array s. We are going to initialize the I, that is the special variable we are going to take that acts as the index variable in my for loop. Okay. So first we will check whether the top is marking at -1. So if top is marking at -1, it is the condition what? Stack is empty. So I will print the error message as stack is empty and return back to the place where the in the main function where it is been called, where the display is called. Else if this condition fails, top is not marking at -1, that proves that some more elements are available in the stack body, hence we need to print it. So this if body will be not executed, it will go to the next line, that is printf. First line it will print as contents of the stack. So next it will start printing the for loop. It will start executing the for loop. It will start from the 0 and it will print up till top where it is marking at. Okay. So this is the way how we do display the contents of the stack. So here in this video we have understood about what is stack, the definition of the stack, what is the property that stack exhibit, that is LIFO, last in first out, and we have seen the various operations of the stack, that is push, pop and display operation. With that we have also understood about the stack overflow condition as well as the stack underflow condition. So lastly we have defined different functions for these different operations. So let us go with the programming for this particular. We will go and check for the C program for the stack operations. I am using Turbo C editor or the Turbo C C++ software to run the program. So here is the program what I have already typed. The first line of code indicates with hash as the starting character any statement in the C program starting with hash, they are called as preprocessor statements. These preprocessor statements are those statements wherein already the content will be processed. There is no need to check further. So here we are going to include the library files that will support for the various other different functions to be executed. So the first line of code is helping me to include stdio.h. It means standard input output library file will be included. In this standard input output library file, we are going to have the definitions of various other keywords. So basically keywords are what? Keywords are those predefined words that are having certain functionality. So if I use directly those keywords, certain functionality will be exhibited. So this functionality is defined in the header file, that is the library file stdio.h. So it might be any keyword, it might be like integer, it might be if, it might be printf, it might be return, it might be scanf. So these are all keywords. The definitions for workability or functionality of these keywords are being explained in the library file stdio.h. .h represents what? Header file. So in this way we will include all those different library files what we need to execute in my program. So the first line is I am including stdio.h. Second line I am including process.h. Process.h header file is used to see that I am including one process. So already you have studied the operating system subject, and I hope you know about what is process, how the process is created, and how the process is utilized. Okay, so same type of process I am going to create here using the process.h, wherein I am creating a new process to see that I am using this arrays to behave as that of a stack data structure. Okay, so next line of code is I am including conio.h. So this will be the special type of header file or a library file what I am going to include in my code. I will tell you in the further instructions why I am going to use this conio.h and what it is going to help me out for. Next I am going to define the stack size as 5 using the preprocessor statement define. Okay, I am going to take the stack size as 5. The highest size will be what? 5. Okay, then I am writing all those push, pop and display functions here. I will explain it one by one. So main function I will start with, as because the name itself defines that my program execution starts from the main function. Okay, so here in the main function I am going to declare first all those variables that I am going to use in my program. So the variables I am going to use in my program are the top pointer, the stack that represent done by the array s. The size here I am taking default as 20. The next variable I am going to declare it as item, to see that whatever item I want to insert I will do store in this variable. And next I am going to go for declaring the variable choice. This choice will help me to select from either one of the choices what I will make here. So like if I want to do the push operation, I will go for the choice number 1. If I want to go for the pop operation, I will go for the choice number 2. If I want to go for the display operation, I will go for the choice number 3. In the similar way, if I want to go for neither of the 1, 2 or 3, I want to exit out of my execution console, I will go for option 4. Okay, so that will be stored here in the choice. So let me first take the initial condition of the stack body, that is the top pointer pointing at the -1. So I am declaring or I am defining the value of a top as a -1. The next line will tell about some function called as clr_scr. It defines a clear screen function. The clear screen function will clear my screen and it will remove all those previous output lines what is there available in the output screen or output window. Okay, so whenever you execute a program, it will be full clear and it will be not having the previous output content in the output window. Okay. Next line of instruction is the for loop, that is will be executing infinite number of times. Here we don't have any initial condition, we don't have any termination condition, and neither we have either decrement or increment. Okay. So this way of defining the for loop is what to execute the loop for infinite number of times. So here in this for loop body I am going to write the rest of the code. Okay. So I am printing the way like a menu. So first option or the first choice is for the push, the first choice is for the push, the second choice is for the pop, the third choice is for the display, or if I don't want to perform any other choice or do any other operations, I will go for the fourth choice, that is exit. Okay. So in the next line I will make what choice I want to do, either I want to go for 1, 2, 3 or 4. So that will be read by the scanf statement. Scanf statement will help me to read the input from the keyboard. Okay. So that is, here I am reading the choice either 1, 2 or 3 or 4. So based on the choice what I have made, either 1, 2 or 3 or 4, my switch conditional statement will switch according to that. So as accordingly 1 means what? Push. So that is the logic for executing the push operation will be written in the case 1. The logic for executing the pop operation will be written in the case number 2. The logic for display operation will be done in or written in the case number 3. If suppose neither of these 1, 2 or 3 should be executed, it will go for the default case. Okay, that is exit. Okay. So as accordingly in the case 1 we have written the push operation or push function logic. So for that I have defined some more meaningful statements. First I will accept the item that is to be inserted. So here using the scanf statement I am going to receive the item that I am going to insert in my stack body. Okay. So here I am going to send the item as the value to the functional call. So the item value whatever I do insert, I will be sending that, and top value will be sent. So here top is initialized as -1. So the initial value of a top will be sent through the case 1 or the push operation is -1, and whereas the stack empty stack will be sent. Okay. So once we do call for this push function, it will go for the push function execution. So the item value what we have entered will be received here. Top value is -1 at the beginning, and empty stack will be there available, or empty array of the SC will be available. So we will check first the condition whether stack is overflow or not, as we want to insert the element. If stack is overflow, we cannot insert more elements in that. So that is what the first case what we will understand. So top value is what? -1. Is -1 is equal to 5? What is the stack size? 5. Stack size -1 is what? 4. Is -1 is equal to 4? The condition fails. It will not execute the if condition. It will directly go to the next line, that is star top is equal to top plus 1. The initial value of a top is -1. -1 plus 1 will give the value as 0. So top will move from -1 to 0, and there at the position 0 it will insert the first item what we have entered. Okay. So this is the way how the push operation executes. Once this first item is inserted, it will go back to the location in the main function at the this function. If I am again going to make in the infinite loop of for loop, I am going to make again 1. It will again go for the case 1 and it will re-execute the same. Okay. So suppose if I make the pop, then it will go for the case number 2. So here the functional call is made here, and the result what I am going to get it from the functional call will be stored in the variable called as item. Okay. So since in the pop operation, you can see the pop function here, I am going to return the item that is going to be deleted. Okay. The item that is going to be deleted. So that item deleted, the value will be carried out and it will be stored in the item variable. If the item what is being deleted is not being deleted at all, then it will be 0. So if it is 0, it will print that stack is empty. Okay. So if item really it is being deleted, then it will print, it will go for the else condition, and it will execute this else part, that is item deleted, it is a print, it will print to the item that is going to be get deleted. Okay. So in this way the switch case will execute. So let us execute this particular code. So before going to execute, I will tell you there is another one function called as the getch function. This getch function will help me to automatically display the output screen, So if suppose I do not use this getch, so at the first step when I execute, immediately the output console will be closed and it will take you back to the editor. So this has to be not done, hence I am going to use this getch function. So once the result is displayed at the first step, next step it will continue further in the same output window only, it will get you back to the editor. Okay. So let us execute this program and check what will be the output. So here we are getting the menu push, pop, display and exit. Push is for the option number 1, pop is for option number 2, display is for option number 3, and exit is for option number 4, as we have the choice listed. So if I make the choice option 1, so it will ask me to enter the item to be inserted. I will enter 10. So first item in my stack is 10. Okay. Next again I will make the same choice 1. So this time again it will ask me for inserting the another element. So I will make insert the element as 15. So first entered element is 10, it will be at the 0th position. The next element inserted is 15, it will be at the 1th position. Okay. Now if I want to display it, you can see the display operation, what it will do, print. First it will print the bottom of the stack value, and next it will print the above value. So first element it will print is 10, and next it will print is 15. Now you can check it. So first it is printing the contents of the stack are, first it is printing 10 and next it is printing 15. So suppose if I use the pop operation, that is if I press the make the choice as 2, so the topmost element or the last element inserted is 15, so it should delete the element 15 first. So you can just check it out, you can see that the item deleted is 15. So suppose last element remained is 10, so if I make a display, it will show the contents of the stack are 10. So if I want to make the pop operation 2, so it will show that item deleted is 10. So the both elements 15 and 10 are being deleted. Now the stack is empty, the top is marking at -1. So if I want to delete the more elements by using the pop operation, that is number 2, it will never delete. Why? Because already stack is empty, we cannot delete. So it will show the error message as stack underflow. If I want to display any element, as since stack is already empty, it will again show the error message as stack is empty. So my line of codes are working good, my program is working good, whatever that we have studied previously. So I will use the example 4, condition 4. So it will execute, it will exit out of my program. In this video we have understood about the stack, we have understood about what is exactly the stack is, we understood about the definition of the stack, and we have understood about the operations of the stack very in detailed way, and we have even understood the C program that exhibits the stack operations using arrays and pointers. So we will conclude this video up till at this point. In the next video we will discuss about the stack applications. Till then, take care, bye bye, and keep watching my videos. Thank you.